Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Srinivas Pattamatta, Vice President at Atmosic Technologies. Atmosic is a fabless semiconductor company that designs ultra-low power wireless solutions to dramatically reduce device dependency on batteries, aiming at delivering a forever battery life and the battery-free connected Internet of Things. In this talk, we discuss the current state of ultra-low power and batteryless wireless solutions for consumers and industry, and we also explore the decision criteria for determining which solution is the right fit based on total cost of ownership, form factor, features, and connectivity requirements. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you. Srinivas, thank you for joining me today.
Thank you for having me. It's my pleasure.
So this is a super interesting topic for me, this topic of low power batteryless applications. But before we get into the company and the technology, I'd love to learn a little bit more about where you're coming from and how you ended up here. So I think you've worked with most of the big players, or let's say many of the big players in this space over the past 25 years or so. Can you just walk us through a few of the highlights of your career, when you first kind of touched on this topic? And then also, why did you end up joining Atmosic? What was it about the company that convinced you to step away from some of the larger players and decide to join a startup?
Thanks for it. My name is Srinivas Pattamatta. I am the VP of Marketing and Business Development at Atmosic Technologies. Yeah, like you said, Eric, if you rewind the clock for about a couple of decades or so, I started my career in what I call wireline technologies. This was a company called Level 1 Communications that was bought by Intel. We were doing Ethernet and wireline technologies, but it's still in the communication domain. Later on, I did a long stint at a company called VLSI Technologies, which was bought by Philips Semiconductors. In those days, it was still Philips Semiconductors. And that's where I moved from the wireline technologies into wireless, where I started focusing on Bluetooth communications. I'm probably dating myself, but in those days, we were doing Bluetooth 1.1. That is a version of the specification, selling into the candy bar feature phones. The thin, long ones had a very small screen, or in some cases, no screen at all. And then moved on into Wi-Fi and Bluetooth at Atheros Communications. They were the premier provider for Wi-Fi. It was started by Teresa Meng from Stanford University. She's still teaching there. She's a very well-known professor. And then, of course, those of you who are following carefully know that Atheros was bought by Qualcomm, so did a long stint there. And then I did a brief stint at Synaptics, the touch company. And during that time frame, I was approached by Atmosic Technologies CEO, David Su. David and I worked together in Atheros for maybe about 15 years or so. He was VP of engineering. I was on the marketing side. Together, we actually worked together on multiple chips and really had fun doing that. And then David and a couple of others were just founding this company called Atmosic, focused on low power and energy harvesting. And more importantly, it had the same blessings of few of the folks that had founded Atheros or were instrumental in Atheros. And so what made me join? I said, look, I had worked on communications for more than 2 decades, and low power was becoming more and more important. of course, I couldn't resist working back with a big portion of the Theros team. And that's what made me join. I joined Atmosic Technologies more than 4 years ago, just after it was founded. I was the first non-engineering employee, meaning whether you HR, sales, everything I was responsible for. And then we grew over time. When I joined, I think we were a handful of players, and now we are in probably hitting like 80 or something like that employees. So yeah, it's been a fun ride so far. And I joined because I love communications, I love wireless technologies, and low power is something that is what we believe for the next couple of decades is going to be very important. So that's the history of where I've come from. Oh yeah, I've always been in semiconductor for the last 2.5 decades or so. So I enjoy it. It's a challenge, but I enjoy it.
Yeah, great. Well, it's been a fascinating space to be in, right? No way to get boring when you're in that space, right? In the past couple of decades, and it's a luxury, really, that you're working with a team of people that you know well, right? That's
Yes.
a big advantage as a company, and just probably a nice thing to do personally. Before we get into the technology here, maybe you can just explain the value proposition. Why is batteryless technology an important addition to the portfolio on the market?
Yeah, I think it's a fair question. So if you kind of step back, the mobile phone probably in the last 10 years has created opportunities beyond what I call hosted systems. Hosted systems are mobile phones, access points, laptops, tablets, and all. So the next couple of decades growth is what they call the edge of the cloud, or some people call it IoT, Internet of Things. End of the day, the two important features for devices on the edge of the cloud are the communication is wireless, naturally, many of the things today are. And more importantly, they are what I call true wireless systems, meaning even the power supply is not, there's no wire for the power supply. So obviously they run on battery or some form of energy harvesting solutions. So in those cases, battery life is fairly important because edge devices either they require frequent change of batteries or they're at a location where changing batteries even every 6 months is a big chore, especially in industrial systems. So in those cases, the purpose for Atmosic and the tagline for Atmosic is we want to redefine battery life. We want to change how battery life is viewed for multiple reasons. One is, I think, the obvious business value proposition for your listeners is, yeah, you can reduce the cost for ownership over time. Instead of replacing 10 batteries over 10 years, if you were to replace only 3 batteries, it's not only the cost of the battery, but the replacement cost, especially in industrial and enterprise environments, is pretty big. On the consumer side, the value proposition is it's ease of use. If you have a remote control or an advanced remote control, and you have to change batteries every 3 months, just when you really need it is when the battery generally tends to run out. And so the ease of use is important for consumers. And there is an important benefit as well. If you're a company that is shipping consumer products or any products in the millions of them, and then each of them is using batteries every 2 batteries every 6 months, it adds up very quickly. So for the environmental impact is very important as well. So overall value proposition is cost of ownership, ease of use, and environmental impact that we could make on what I call IoT edge connected devices. That's the value proposition of Atmosic.
Okay, clear. Yeah, there's an old McKinsey case study that I read in my MBA program, and it was basically somebody invented a light bulb, and the light bulb can last for 50 years, and how do you sell this thing? And the answer was, you sell it to the users where the cost is not the technology, the cost is the human labor of replacing that light bulb. So find the situations where it's most challenging to replace that light bulb, and then you can sell it for a good premium there because it's such a hassle to actually make that change. And I suppose it's a little bit the same here. There's a set of use cases where
the cost of actually going out and finding that sensor and replacing it is quite significant. It could be embedded in a machine. It could be out in a field somewhere. Are there a handful of top use cases where you say today this is where the early adopter market is, where there's so much pain in tracking down these sensors and maintaining them that people are willing to really pay a premium for a solution like this?
Absolutely. So there are a couple of areas that I'll touch upon. First of all, once again, if you step back, like you said, Eric, there's a data point that we heard recently that the install base, it's not a yearly shipment, but the install base of wireless devices worldwide is approaching somewhere around 30 billion units. Now, granted, all of them are not Bluetooth, all of them are not Wi-Fi only, but there are many connectivity solutions in there. And a big portion of them tend to run on batteries. There are two sub-value propositions we are bringing to the table. One is extreme low power wireless solution, and then energy harvesting. If you combine these two together, it's a very, very powerful mechanism. Where does it help? Which applications we see as a low-hanging fruit that we are seeing a lot of interest is, I'll break it up into two buckets again. Imagine consumer applications. In consumer applications, solutions like keyboards, remote controls, wearables, and off late, specific home automation devices like door locks, we are starting to see strong interest. Why? Just like how you said, if you have a remote control or a keyboard, or better yet, a door lock, if the door lock is automated or it's connected through your phone and you can operate the door lock. Imagine just when you're getting groceries and after 6 months, if the battery runs out, it's a convenience issue. On the industrial enterprise side, the fastest growth for Bluetooth 5.0, we can get into it later on what Bluetooth 5.0 entails, is in asset tracking, beacons, sensing, and locationing solutions. Here, the end device is operated by an industrial customer for various purposes, like we talked about, either to track an asset or for sensing a temperature or sensing pressure or sensing light, or even for locationing purposes. Imagine a large airport or a large stadium where you have location beacons. In all these cases, it's not the cost of replacement of the battery, but having to send someone and kind of replace the battery. You have to pay someone, maybe depending on where you're located in the globe, maybe in the US, like $20 to $30 to just replace a $1 battery or even few cents battery. One good example we heard recently was an average hospital in the US has about probably 50,000 equipment that they like to track. Imagine if you had a small coin cell device that you're tracking, that you're using to track all these equipment. And if each of them kind of run out of batteries every 6 months, then there's someone replacing 50,000 of this. It's, I call it like painting the Golden Gate Bridge. You start with the first device, you replace, and by the time you finish the 50,000 device, you come back and replace the first one because it's 6 months over, right? So the total cost of ownership, it's not just the beacon device that you're putting on the equipment, but paying someone to replace that. That's called total cost of ownership over the life of the solution. Suddenly adds up. So where we are seeing traction is tracking and location on the enterprise side, and some sensing devices as well. And on the consumer side, we're starting to see, as I said, remote controls, keyboard, and wearable solutions and home automation.
And so this is quite a range of different applications. So I imagine maybe you can tell me what's the product strategy? Are you selling sensors? Are you licensing your technology to different sensor manufacturers? Because I suppose you need quite a range of different solutions for these portfolio of use cases.
The product strategy is, we are a semiconductor company or IC company, as someone like to call. We are developing chips/semiconductor solution. And what we are doing is to enable, like you said, all these couple of handful of applications. We have created reference designs. And in each of these subsegments, keyboard, remote control, asset tracking, sensing, we have partnered with various module providers or solution providers who will take our chip/semiconductor solution, integrate it with a few other components, and sell it into the market space with large OEMs, whether they're a consumer OEM or an industrial OEM. So to enable this, we have created reference designs so that our partners can manufacture the complete solution much quicker and easier. And we can get into more details later on what the semiconductor solution that we are selling consists of and what are the details in it. But at a high level, in terms of the value chain, the way we are enabling is creating reference designs. We don't sell the reference design, but we provide it to our partners for easy manufacturability and integration so that they can go and spawn off and build to multiple OEMs in the market space.
Makes sense. And if I understand the key components, at least at a high level of the solution, you have a very low power radio on Bluetooth 5, so that reduces the energy requirement. You have on-demand wake up, so that the system doesn't need to be on and expending data or energy all the time. It can turn on when data needs to be sent only. But then you have this other component, which is the energy harvesting. If we can just dig in there a little bit, because I guess each of these different use cases, it has a different environment. So where the energy is coming from, could differ. Am I right? Or is there a standardized energy source, or where is the energy coming from in these different use cases?
No, you caught onto our base technology pretty well. So there are three main components our complete single chip SoC consists of. The base component is a very, very low power, standards compliant Bluetooth 5.0 technology. We started with that baseline because we wanted to keep the energy consumption of the connectivity portion extremely low. The analogy I give people is if you consume less, if you're running a marathon, if you're able to run the marathon by just eating a small power bar or salad rather than a full meal, you still are able to do the same work by consuming very less power consumption. So, number one, like you said, the patent and the secret sauce that we have developed over the last 2 decades, the team that we've assembled, who have come from Qualcomm, Atheros, and many other large wireless companies, especially the core team has worked together for the last 2 decades, as I said, in Qualcomm and Atheros. We've kind of honed in the low power wireless techniques. There's a multiple of those patents that we have. So base is, like you said, low power wireless. But the most important point there is it's standards compliant. It's a very standard solution so that it's able to talk with a large tens of billions of install base across the globe. In this particular case, we've chosen Bluetooth 5.0 for a couple of reasons. One is that it's the connectivity of choice for indoor IoT devices. And more importantly, Bluetooth 5.0 is growing or pivoting compared to the earlier solution of Bluetooth. It's ideally suited for mid data throughput or low data throughput IoT devices that require same range as Wi-Fi. Bluetooth 5.0 can go up to 100 meters right now, compared to the Bluetooth 10 years ago, which could only do 10 feet. That's number one technology. Number two, like you said, so these are all cumulative technologies, 3 technologies. One is Bluetooth 5, very low power. Number two, imagine there are applications where you don't need to be transmitting and receiving constantly. Imagine an asset tracking device. You just told me you're actually somewhere in Asia. So imagine there are 100,000 assets that are loaded onto a ship and they're sent from US to Asia. It takes about 2 months. Why should all these assets be beaconing their location? Instead, you could actually turn all of them off. That is what is called wake up receive. You can use any existing tablet, access point, or phone to put these devices to sleep using a magic packet, a predetermined magic packet. No other Bluetooth solution does that. And then what you do is when you land, you send a magic packet again, and all these devices wake up. That's the second order of magnitude of savings you get. And the third order of magnitude is by doing energy harvesting. You can harvest energy to compensate for, you can do three things. Either when you have when you have energy, you can use it to supply to the solution, or number two, you could actually store it on a battery or a supercap. Or number three, in some cases, you don't even require a battery. You can just take the energy harvested and supply to the solution, and then the solution can transmit and receive. Now, you asked me a question about, hey, Srinivas, what about the types of energy harvesting? Do you have only one? No, not at all. Today, we support four kinds of energy harvesting. We support RF energy harvesting, we support photovoltaic or light, we support mechanical, and we support thermal. As you can see, these are four different types of varied energy harvestings. Depending on the solution, depending on the environment, you could pick one or two of them. Let me give you an example. Imagine a wireless keyboard. In fact, there are wireless keyboards that exist today which have photovoltaic, i.e., solar cell on top of them. You could use solar. In our case, you could also use RF. Where is the RF energy coming from? When do you use wireless keyboards? You use it when you're typing in front of your laptop or your large PC solution, all-in-one PC solution like an iMac or something like that. The Wi-Fi coming from these devices can be used to power the keyboard, or maybe you can even put a dongle where you can transmit 900 megahertz or some other wireless RF source. In terms of photovoltaic, well, photovoltaic, you could use the light inherently inside a room. So the answer to your question, if it is RF, we do have an RF source reference design we could provide. We took an off-the-shelf components. You could put it in a dongle and use that. Or you could use an inherently existing wireless solution as an RF source. The examples are, you could use the phone to power the door lock. When you bring the phone closer to the door lock, the wireless inside the phone could act as a RF source. Or as we talked about earlier, we could use the laptop or the all-in-one wireless solution. Or in some cases, you could actually install your own wireless source, either inside an access point or elsewhere, to provide RF energy. The chip SoC solution has a couple of interesting techniques inside it. Number one, we already talked that it consumes 5 to 10 times lower than any Bluetooth solution in the market space. That itself enables even modest energy harvested allowing the chip to transmit. Number two, we have a advanced power management unit that can take in multiple inputs. It can take multiple RF solutions, multiple energy harvesting solutions, RF, photovoltaic, or other kinds of harvesting, and it can modulate between them. It can pick and choose between a battery, between an RF, or between a photovoltaic, and say, hey, this seems to be the best energy source so far today. So this is the system intelligence we have buried into this chip that will enable the end consumer or the end OEM or the end industrial customer to design the solution much easily. Put the chip, add few components, and then you have the complete solution.
So let me just ask a couple of questions to clarify how this would work. Maybe two questions here. One is, how much energy is sufficient? So let's go back to this example of the door lock, right? So you mentioned that the RF coming off of a mobile phone might is maybe sufficient to power the door lock. Is it necessary then when you open the door to have that? Or I guess is there a battery that is basically being recharged kind of passively throughout the day whenever there is an RF source nearby so that when you open the door, it's available? Or do you need that RF source to be active at the point when you want to use the device so that it has an active energy stream? How do you make sure that there's the right amount of energy, when you need it? Because I imagine some of these energy sources will be transient.
Yeah, of course. So the way to think about whether it's door lock or keyboard or remote control or anything, the way to think about that issue is bucket it into two buckets. One is solutions that can run without batteries and solutions that run the batteries for the life of the solution. In the consumer examples, most of the OEMs are launching with a battery. And if you buy a remote control or keyboard, the OEM is happy to ship batteries along with it. That's not the problem at all. The problem is they want to ensure that the batteries last long. In our example, if you take an average, if you just take a keyboard because it's much easier for people to imagine. If you take the keyboard, you could do one or two of the things. First of all, you can include the battery with it. And second of all, you could put either photovoltaic strip, couple of small cells on top of the keyboard, and or you could use both. You could use the RF energy coming from the laptop. In both cases, you could have a rechargeable battery in it, or you can put a super cap next to the regular battery, AA, AAA battery, and charge it on that. And so when energy is available, you could dump it onto the inside the rechargeable battery or the super cap and use it. Or when it is not available in those corner cases, you could use a AA, AAA battery. Just to give you an example, an average user using our low power Bluetooth and energy harvesting solution, an average user who types few hours a day, and if it's in a regular environment of a regular room, which is at least about 300 to 400 lux of light available, the battery can last maybe about 7 years or so. That is kind of life of the solution. Usually, Eric, you or your listeners probably replace their wireless keyboard every 5 to 6 years, or maybe every 5 to 7 years. So for the life of the solution, you don't need to replace the battery in that particular case. So yeah, to answer your question, yeah, in all of these cases, there is an energy source either transiently present. In the case of door lock, it's present occasionally when the phone comes close by. In other cases, it has a battery in it. But if you go for an advanced implementation, imagine a hotel door lock, because the doors don't, generally you don't move a door, meaning you don't physically move the door to somewhere else, like a wireless keyboard. The door is stationary. In those cases, you could imagine hotel installations where there's an RF source sitting on top of the frame of the door for every door. Hotels don't mind installing that because today they pay a lot of money to replace the batteries every 6 months, because all the door locks in hotels nowadays run off of batteries, basically. You cannot hardwire them because when you open and close the door, the wire gets kind of shaped. To answer your question, yeah, you can either use an intermittent RF energy source, i.e. a phone, when you bring it close, or you could have a permanently installed RF energy source on top of the door frame that supplies power on a regular basis, RF energy power on a regular basis.
Okay, interesting. So it's kind of virtual wiring. You can basically have the effect of a stable wire of energy, but it no physical interface.
That's correct. That's correct. When you use photovoltaic, you can definitely use ambient photovoltaic. Later in the call, we can talk about how we are working with a couple of customers on using ambient photo energy or light source inside your room for remote controls and keyboards that we are working today.
Let's say we've touched on a couple of use cases already. What would be the upper threshold for the amount of data that could be transferred? So what's the upper threshold for the type of use case that could be feasible with this based on And I guess it depends, because you could have maybe a very powerful RF feed that's actually streaming a lot of data, but maybe there's some edge cases like that. But in practical terms, how much data is kind of the maximum that is, typically going to be transmitted in this type of solution?
In the solutions that we are selling today, all of our solutions are Bluetooth 5.0. So the limitation is based on Bluetooth 5.0 data throughput. The maximum you can do is in the megabits range, single megabit range, basically. And if you do have a photovoltaic source, then you can transmit in the hundreds of kilobytes to a megabyte in terms of the data that you could transmit. If you have a decent, in terms of the photovoltaic energy source is probably the most stable one, assuming you don't turn off and turn on the light every microsecond, which is a kind of a crazy case. But in a standard room that we're all living together, you could probably do hundreds of kilobytes up to a megabyte of data throughput. If you're getting into the tens of megabytes, I think then today's energy sources cannot support that, because you have to break the problem into two. One is energy consumption and how much can you harvest. Energy harvesting is relatively only a few years old. We believe it's got long legs for the next 2 to 3 decades, basically. So there'll be a lot of improvements that will be done not only by Atmosic, by many players in the market space over the next 10 to 20 years. And we believe in there's a lot of future for it. And when that kind of goes, the efficiency of energy harvesting solution becomes a couple of orders of magnitude. That's when probably you can get into the tens of megabytes. Until then, you're into the hundreds of kilobytes to megabytes of data. In asynchronous cases, you could accumulate the data, meaning if you don't need to transmit in real time, you could accumulate as much data as you want in an external memory source and transfer as and when needed. So then your average throughput over time could be pretty high as well.
So just to give a little bit of a benchmark here, if we go back to your wireless keyboard example, how many kilobytes, what would be the data rate that would be required for that product?
Yeah, unless you're typing fast and there's a lot of other unless you have a special keyboard which is sending additional stuff, you're probably in the hundreds of kilobytes of data, I would say, or even less than that in some cases. If any of your listeners go into YouTube and just Google Atmosic keyboard, you will see a keyboard our CEO is typing on, and it's kind of getting RF energy source from a dongle which has 900 megahertz RF source and doesn't have any batteries. And he's typing normally. He's not the fastest typer in the world, but he's typing like regularly. And that is more than sufficient to run without batteries, actually. That kind of tells you how quickly you can harvest energy and transmit back quickly.
You mentioned this is a fairly new technology, and you have, I guess, a couple of different things that are being improved by all of the companies in the ecosystem here. So you have on the one side the RF improvements, related to Bluetooth, and there'll be continuing upgrades there. And then you have the energy harvesting. What do you see as the big technical levers for improving this field of batteryless energy? So where are the areas where you say, okay, we can't just get a 10% improvement, we could potentially get a 10x improvement over some period of time? And are there particular domains that are that are exciting for you when you look out into the next 5 years or 10 years of the technology roadmap?
Yeah, absolutely. I think, first of all, we started with improvements in wireless power consumption. I want to remind your listeners on that. The wireless active power consumption of our solution is 5 to 8 times lower or 5 to 10 times lower, depending on which competing solution you're talking about, apples to apples comparison. So I do believe we have already introduced into a market something that is kind of game changing in terms of the wireless power consumption. In this particular case, we've chosen Bluetooth 5.0. So you could imagine applying similar low power techniques for other wireless connectivity in the future by Atmosic. You can name many of the other wireless technologies that are popular or upcoming that Atmosic could work on. So I think that's one layer. Imagine two pillars that we will continue to work on. So that's one layer of innovation that we will continue. We will take what we have developed on Bluetooth 5.0, similar techniques applied to other wireless technologies. Imagine now you're only doing what we call data solutions only. We could apply that to audio and video in the next 10 to 20 years. That's a long-term vision I'm painting. Now, on the energy harvesting side, there's a whole lot of things we could work on without even touching the ecosystem. I'll talk about the ecosystem in a minute, but we can continue to do improvements in terms of how much energy is harvested, how the efficiency of the energy is harvested. I just gave you an example of our existing solution where we have integrated advanced power management unit where you don't waste the energy. If you had two types of energy coming in, most Bluetooth solutions cannot pick both of them. So instead of wasting that, we're able to pick both those solutions and kind of integrate that and use it for transmitting data. So that's one level. And I would say the whole energy harvesting and improvements in the efficiency of energy harvesting in the next 5 years, we could not only Atmosic, but other energy harvesting companies as well could spend quite a bit of time and resources improving an order of magnitude in terms of the efficiency of the energy harvesting. And then finally, the ecosystem players, those who manufacture photovoltaic cells, those who manufacture thermal generators, those who manufacture mechanical generators that complement our solutions, that continues to happen as we speak. We are talking to many partners like that. And I believe in photovoltaic, a lot of advancement have been done and continues to happen. The next one probably is RF and thermal, I think, along with mechanical, that you will see in the next 5 to 10 years.
Gotcha. Okay, great. So some levers that will continue to be worked on here. The cost of the solution is not something we've really touched on. I mean, I know there's certainly actually before we go there, I wanted to follow up on this point around alternatives for different connectivity solutions. There's this whole array of use cases around low power, wide area. So if you think about agriculture, areas where you might have sensors out in the field somewhere, and that I guess is a very significant pain point, even identifying where the sensors are, let alone having somebody go on and change them or change the batteries. But there you're really looking at situations where it has to be completely passive, so you're not going to have any local RF energy source, and then you have this challenge of kind of wide area networks. So you're moving data farther. Is that something that you've looked significantly into? And I mean, I guess Bluetooth is not going to be the solution there. But what's your view on that particular category of use cases where you're moving things maybe kilometer, kind of in that range?
Yeah, so we haven't looked into the kilometer, the wide area network. Certainly, the technology that we're developing can be applied there. Currently, we are just focused on Bluetooth, but you could imagine the low power wireless techniques could go beyond that. Our hands are full. Just Bluetooth 5.0 endpoints today are about 1 billion units, growing into about 2 to 2.5 billion units in the next couple of years or so. That's a pretty large market for a startup like us. So we're happy to focus on Bluetooth for now. But you can imagine in the future, we could use this technology into many other areas as well.
Yeah, great. Okay. The typical BOM cost, I mean, I know this is going to be the answer is going to be to some extent, it depends. And it's somewhat also out of your control, right? So other manufacturers are building the solutions, but are we looking at order of magnitude, $1, $10, $30? What would be a typical BOM cost for a solution?
Yeah, I think we should just start with the existing BOM cost of, imagine Atmosic was not in the play. What is the existing BOM cost? Generally speaking, if you took a regular keyboard and you said you wanted to add Bluetooth module to it, it's in the few dollars range, the Bluetooth module coming from a competing solution. Now, you're adding, I would say, probably less than $1 BOM of adding a photovoltaic cell and also is from few components to it. So the additional BOM cost for adding energy harvesting is not significant. And from Atmosic's Bluetooth solution point of view, we are very comparable in terms of the chip costs, chip ASPs, I would say, not chip cost, chip ASP, SoC ASP compared to what competing Bluetooth solutions are, because we are manufacturing it in a very standard CMOS process.
Okay, great. So yeah, pretty minimal impact on the actual cost of the final product here. What have we not touched on yet that's important? What questions should I have been asking here?
I think you kind of touched upon in the beginning of the call. You said, "Hey, what are some of the things that you worked on? Where are you seeing?" I think when we started this venture a few years back, I think we just started scratching the surface. In the last 1 year, we're seeing a lot of interest in the OEM space of consumers, and namely because consumers are demanding for two reasons that they want to extend the battery life. One, for the consumers are becoming more and more conscious, and secondly, it's the ease of use that we talked about. Sometimes one of the important point I would like to stress to the listeners is don't think of it only from a cost perspective. Imagine it from a feature perspective. What do I mean by that? Let's take remote controls, for example. All of us know in the last couple of years, remote controls, you could have thought, if you asked me 4 or 5 years ago, yeah, remote controls for TVs is great, but okay. But in the last 3, 4 years, remote controls have pivoted. They have voice processing built into them. Whether it's many of the voice engines that are popular ones, whether it's Alexa, Siri, or Hey Google, or many others, all of those are being added to that. What does it mean? That means you're going to actually consume more and more power. So, for the same battery life as a regular remote as before, by going with an Atmosic solution, a low power wireless solution with energy harvesting, now you could add these additional features and still keep the same battery life. That's one of the things we provide. Not only just extending the battery life, but you could actually take the energy that we provide, keep the same battery life as before, but now you add more features. It's kind of the quintessential more for the same price kind of a deal. The other way of looking at it is you could also kind of go ahead and design better form factor solutions. Previously, you were putting two double A's. Now you could just put a coin cell and just go with a very thin remote control. So the possibilities of energy access, as I like to call it, are you can go in many vectors. You can go in the vector of cost, you can go a vector of life of the solution, you can go in the vector of form factor or feature addition. So that's an important point that we all have to kind of keep in mind as more and more features are being added to everything around us. You could go in many ways by using a solution that Atmosic is providing. That's probably what I would add in the end.
Yeah, no, that's a great perspective. That in the end of the day, adding or subtracting $1 or $2 from the BOM is not going to make or break a product. But being able to differentiate on form factor and on features is what will dictate the success of these products. It's funny. I don't know when the last time is that I owned a TV, but it's probably been 10 years or something. So this whole example that you were giving about the new remote controls is I just had no concept of.
Just a 1 minute on that is that worldwide, not just TVs alone, but across all kinds of remotes, fireplace remotes, all kinds of remotes, worldwide, ABI research says it's 1 billion units every year. Out of that, about 400 million are Bluetooth remotes. So, and out of that, about 200 to 250 million are TV Bluetooth remotes. So it's a pretty large market space. And that market space is pivoting. People are adding voice processing, voice front ends to everything possible, including remotes.
Yeah. No, interesting perspective. And this wireless concept as well, I think. So if you can, maybe this is something looking, a little bit forward into the future, but would you imagine if we look forward 10 years or some more considerable amount of time, being able to eliminate more wires? Are we looking forward towards a time when a light, for example, I mean, maybe that's an extreme example, but we have all of these wires in the house that are connecting different types of devices. And people spend a lot of money on designs that somehow minimize this. And they spend a lot of time on either by themselves or they hire people to kind of figure out clever ways to hide the wires and embed them in walls and in floors and so forth. But if you look forward, do you imagine that it will be possible in, let's say, a 10-year time frame to start powering some of these really higher consumption devices with batteryless solutions? Or is if we're looking at a light, for example, is the energy consumption simply too high to be really feasible?
No, I think your thread is the correct thread. Imagine a decade or even 2 decades from now, which is all of us have more and more wireless solutions in the house, not only just hosted systems. You have endpoints, you have sensors, you have temperature sensors. Imagine that 10 years from now. And why just pick only one energy source? Think of mechanical, RF, light, thermal. And based on the end device, you could use 1 or 2 of those energy sources to power them. Maybe not every minute of it, over time in 24 hours. You don't need to be powering all of these things and blasting energy every second of it. You could do it in the night. You could imagine an intelligent way of, imagine the whole building and imagine the whole building is energy supply. Energy sources could be controlled. And those can power all these endpoints over time in the night, maybe, or during quiet periods. And then just extend the battery life or maybe not require batteries. So if not all of the solutions in the house, at least a big portion of the solutions that run on AA and AAA. Imagine all the toys that are running around in the house. Imagine all the smoke detector alarms that are in the house. All these could be powered using energy harvesting solution and on top of that connected wirelessly to transmit data and be connected. So yes, our long-term vision is consumer or industrial or enterprise buildings a decade from now. If not all the solutions, at least a good portion of the sensors and all kind of utilizing energy harvesting, but still connected wirelessly to transmit data. And that's the longer-term vision for someone like Atmosic.
Okay, great. Well, super interesting space that you're in, and that's a great vision. I think many people would be happy to see that world come to fruition. So, thank you, Srinivas, for taking the time to explain your work with us and introduce the company, and wish you all the success in the world.
Thank you so much, and it's my pleasure talking to you.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.